So here's the project. This is a transient thermal case, and the generic data is very basic geometry. I can show it in a design modeler, which is actually nothing more than a couple of solids boxes here. So 1, 2, 3, 4, 5, 6, 36 boxes, and here is the model. This is the geometry. The material is just default structure still. I'm going to change that in the future. Contacts, actually all of them bonded solid to solid. Mesh is very coarse mesh, you can see here. The initial temperature is 22 degrees centigrade. Analysis setting, I've just put it as 1 second for the first step and 5 seconds in total. Convection is going to be 22 with a film coefficient of 20. That's for the convention, and I'll assume that there is a heat flux of this size, 1 to the power 7 watts per square meter for the face only on this one, and that's where I've got the results. I can just quickly solve it again. I haven't done any changes, but it should be the same as what I've done before. A couple of seconds until it finishes. Excuse me. For the animation, just put it at 100 frames, 20 seconds. And that's what it's showing. It's telling me that the minimum is 22 degrees reaching to 182 maximum. What I'm looking for actually is adding the evaporation. So I wanted to add a constraint or a rule that says if each one of these elements, or if we refer to the solids, the boxes, I'm not sure the capabilities in here. How can I add a rule like APDL program to say if any part of the geometry, like these solids or the mesh or any element, reaches 100 degrees centigrade, it's going to evaporate? Because, as you know, if it evaporates, the source heat is going to be gone. So I think the temperature gradient is going to be different. So that's what I'm looking for. I cannot find anything here. I don't know how to actually write APDL. I'm not sure where to put it. I put a couple of APDL in transient thermal here, or in the solutions, but I messed up. I didn't do it correctly. So that's what I'm seeking help for. Thanks.